Guys, I wanted to go through this pretty tricky problem where I asked you to find the oxidizing agent and the reducing agent in this reaction that I have written here. And so in order to do that, we need to determine the oxidation states of all of these elements. The easiest thing to do to start is to go through anything that is in its elemental state, which would be 0, or if it's just a monatomic ion. And so we have two monatomic ions here. We have manganese 2+, and we have hydrogen. So the oxidation states for these are just going to be the charge that is associated with them. So for manganese, it will be +2, and for hydrogen, it will be +1. Let's make that a little bit easier to see. Okay, so now everything else is a little bit more challenging, and that's what I wanted to go through with you. The water is probably the simplest one of these. So we have H2O, and we know that oxygen is always going to be -2 oxidation state. You went through the rules. And hydrogen is almost always going to be +1 when it is combined. And that makes sense because we have two hydrogens here. 2 times +1 would be +2. Combined with -2, this oxidation state total, oxidation number total, adds up to 0 for water. Make it a little more clear there. Okay, and similarly with this SO2, oxygen is going to be -2. We have two, we have 2 of them. So this is a combined power of -4 in oxidation numbers. And that means that the sulfur needs to be a +4 so that everything adds up to be 0 for this SO2. It gets a little more complicated when we have combined compounds that are also polyatomic ions, like this MnO4 with a negative charge and this SO4 sulfate ion with a -2 charge. So let's go through those. Let's look at our MnO4-. So all of the oxidation numbers in this need to add up. Let me adjust this. Here we go. Need to add up to -1. That means, since we know that oxygen is going to be -2, that means that manganese plus 4 times -2, manganese plus 4 times a -2 needs to equal -1. And you can rearrange this equation and solve for manganese, the oxidation state. So that -1 that I got there, just to be super clear, this is why I'm saying that these need to add up to -1, is that negative charge right there. And we always know that oxygen is going to be a -2 oxidation state. We can even write that in right here. We can write that in all of the oxygens. They're always going to be -2. We're trying to figure out the oxidation number for manganese here. So the way this equation solves out is that the oxidation number for manganese is going to be +7. So we'll just write that up here. And we can do a similar process for our SO4 2-. So similarly, the sulfur's oxidation number, and again we have 4 oxygens, so that's going to be 4 times -2. So this adds up to -8. Together, this all needs to add up to -2. And again, that is because of the charge on this polyatomic ion, so the oxidation numbers need to add up to that same charge. After we do this math, we see that sulfur has an oxidation number of +4. So we will write that right here. Okay, so now we have assigned oxidation numbers for every element in this reaction. And now we need to, oh, have we? Did I mess that up? Oh, I did. I did that wrong. You guys are probably yelling at me right now behind the screen. This is not 4. This is 6. 4 times -2 is -8. We have to have +6, so we will fix that. That's a +6, and that's a -2. There we go. Okay, now that we have the correct oxidation numbers for all the elements in this reaction, let's look at the changes in our oxidation states of each of these compounds, each of these elements. So I'm going to go through, we have manganese, oxygen, sulfur, and hydrogen in this reaction. And I'm going to go through each of those and look at their reactant side oxidation number and their product side oxidation number. So here is, let's just make a little table here. So here's our element. This is going to be its oxidation number on the reactant side, and then again on the product side. And then we will look at, did it gain or lose electrons? Decide if it was oxidized or reduced, and then determine if it's an oxidizing or reducing agent. So that was the original question in this problem. All right, so let's look at manganese first. So as a reactant, manganese had an oxidation number of +7. As a product, manganese has an oxidation number of +2. So did it gain or lose electrons? So this little part is we're talking about electrons. Did it gain electrons or lose electrons? So it went from a +7 to a +2, which means it must have gained 5 electrons. So this gained 5 electrons. Remember, electrons are negative, so when you gain electrons, your oxidation number goes down. So was this oxidized or reduced? Well, remember Leo says Gur, gaining electrons is reduction. So manganese was reduced. And if you are reduced, you are an oxidizing agent. I'm running out of room, so there's my shorthand, oxidizing agent. All right, now let's look at sulfur. So sulfur, as a reactant, had an oxidation number of +4. Sulfur as a product has an oxidation number of +6. This means that sulfur lost 2 electrons. So it lost 2 electrons. Again, Leo says Gur tells us that losing electrons is oxidation. So sulfur was oxidized, which means that it was the reducing agent. Okay, the last two are hydrogen and oxygen, and you can see from the reaction above that oxygen stays the same at -2 in the reactants and -2 in the products. Hydrogen also remains the same. It's a +1 in the reactant side, and it's also a +1 in the product side. So hydrogen and oxygen do not undergo oxidation and reduction in this reaction. And that's how you solve this problem. Hopefully that was helpful.